Welcome, everyone. We're going to start at approximately 1 to 2 minutes. Very excited to have such a diverse number of registrants here from all across the world. So certainly feel free to say hello in the chat, say where you're from, say why you're here, who you work with. I'm really excited to get us started in just a minute. Brilliant. So we already have 41 participants in our webinar. So I feel like now is a great time to get started. First off, everyone, good morning, good afternoon, good evening, and happy GIS Day. Thank you for joining us. My name is Erica Nelson on behalf of the Signal program at the Harvard Humanitarian Initiative and the Humanitarian Geoanalytics program at the Harvard Humanitarian Initiative. I'm very excited to have you all here. Today, we will be speaking about harnessing geospatial methods for atrocity and conflict prevention. We have a group of folks here at Harvard that will be moderating, but I'm really excited to hear our speakers, Christina, Wille, and Jamon van de Hoek, and some of their work. So first off, the obligatory agenda. First, I will start by introducing the Atrocity Prevention Lab, who we are, what do we do, and then we'll move into our individual speaker presentations. And then we've put aside some time for questions and answers. So we really look forward to your participation. As the speakers are thinking, please, or as the speakers are talking, please feel free to put questions in the chat, think about them. We will spend some time really digging into these issues. And then at the very top of our hour, we are going to just have a really brief call to action, because that's why we're all here, is to really bridge this data to impact gap. Oops, apologies. So the Atrocity Prevention Lab, who are we? So the Atrocity Prevention Lab is a project here at Signal to strengthen innovation, collaboration, and the impact of atrocity and conflict prevention work through the integration of spatial methods and technologies. This project was launched in 2023 by the Signal Program on Human Security and Technology at the Harvard Humanitarian Initiative. And so while the Signal program has been around for a very long time, we launched this community of practice to really bring people together, to break down silos, and to really create spatial literacy and collaboration within our communities. So I just said that. What is the what? It is a space for early warning, early action practitioners, technology developers, and academic researchers to come together to share relevant ideas about how do we integrate spatial methodologies into atrocity and conflict prevention in a way that improves our impact. Why? Well, there's a really significant gap between what is being developed by researchers and technologists in high-income countries and at high multi-level agencies, and what methods are really being utilized by communities, local or regional EWEA organizations. After a scoping review that we at the Signal program undertook a couple of years ago, both within the academic literature, but also within practitioners in the community, it's really quite clear that there is this huge gap between what can be done, what can be utilized, and how it can actually impact work, and what is actually being utilized by those community, local, and regional actors. And so we really wanted to bring people together in this method of sharing that information, of socializing and democratizing the space. And so this is one of our lines of effort to do so. Today's APL webinar, very excited to leverage the force of GIS Day on its 25th anniversary to bring to you Christina, Wille, the Director of Insecurity Insight, and Jamon van de Hoek, who is Associate Professor of Geography at Oregon State University at the Conflict Ecology Lab and Decentralizing Damage Mapping Group. here today on GIS Day. It's really dedicated to sharing, teaching, and inspiring others with GIS. So I'm really looking forward to these two conversations. I'm certain that they will do that for all of us. And so with that, I am going to actually transition over to our speakers.
Hi, my name is Christina. As I've just been introduced, so let me see that I managed to share my presentation here. So, to the slideshow. All right, can you confirm that you can see this? Okay, so yes, so hello everyone, and thank you so much for inviting me to speak at this. It's quite a humbling experience because we are neither a GIS focused organization, nor am I sure can we claim that we actually prevent atrocities. But what I would like to do with this presentation is to share with you what we at Insecurity Insight do and how we use geospatial information in our work. So I will go over what we do and hear us and show you some of these sort of images. So first of all, the focus of our work is really that we provide evidence-based information by focusing on events that affect the aid sector, healthcare, education, food security, protection, and conflict-related sexual violence. And we focus on violent events with an impact on these sectors. And then we carry out social media monitoring to protect the humanitarian space, and that is sentiment analysis. And these activities sort of feed together in our effort to try to make the aid sector, in the widest sense, more resilient to addressing violence. And that means for aid agencies of how to access communities in need, but also increasingly of how to support local volunteer and other organizations who respond in conflict, of how they can better protect themselves to continue their important work. A few words about Insecurity Insight as an organization. We are a completely virtual organization. So we're a membership-based organization. We're registered in the Impact Hub in Geneva, Switzerland, but all our members are across the world, and we connect through the internet and collaborate to do our work. We work with a lot of NGOs who were the original partners in our project work. And at that point, we really concentrated on security incidents that affected aid agencies. But increasingly, we've moved into using open sources to document violence that goes much beyond what aid agencies collect within their own work. And so the information that we publicly share does not directly come from the agencies these days, but really comes from open sources. And our story is one of how we moved from using newspapers to these days algorithms to collect this information. And our objective really is to connect relevant information that we believe is out there in terms of incidents of violence, and to bring this together to help us to better understand what is going on. So our focus is not so much the investigating individual incidents, but it is understanding the patterns of violence within particular context and drawing conclusions from this of what can be done to prevent it, to mitigate it, and to work in such a context. And I just wanted to very briefly share you what sort of technology we use to now use these algorithms to collect this information. We use something that we've built for ourselves, which we call the news reader, and this uses natural language supported searches, which means it looks for the context of information in open sources and then classifies it in terms of how relevant it thinks it is for our work. And then we have humans who look at it, check out, do we believe, do we trust the source, do we think it's a credible source, and then we process information. And you can see here on the site, we have these sort of different topics, and then the algorithm suggests, in this case, for example, that this affects healthcare and protection, or in this case, it would be conflict-related sexual violence. And this is then verified by humans, which is sort of called in the technical sense, the human in the loop. And then we share this in these news briefs where we provide a very short summary of what has happened with the link where we invite the community also to respond and let us know if they believe it's an untrustworthy source or if they have additional information. So that's sort of our first step. And as you can see from these event descriptions that we collect, they don't tend to have very detailed geographic information that can be used within information systems. So the additional system we've built is one where we can add the geocoordinates to these event descriptions. And that's what so these are just a few sort of the outputs we would do with this data. So I just want to show you how we move from these text-based information that we collect to something that then has geocoordinates that can be used in a geolocated information system. So here's just one example of a particular event description. And we've built our own database that uses, on the one hand, underlying maps. And then we use from OpenStreetMaps, that system which we've integrated, that we can show the health facilities, or we could click on education or refugees, and then we either see schools or IDP camps. And then we can put in our search function the place that is usually mentioned in the event description that we are collecting through our other systems. And then the system automatically attaches the latitude and longitude to the event. And this is then how it is in the database. And then we can have it as normalized structured data that we share, for example, on the Humanitarian Data Exchange. And then this information becomes usable within geographic information systems to this. One element to perhaps sort of mention here is something that we find quite challenging, is that there is a movement within the sort of humanitarian data exchange that there is a sense that the precise geolocation is somehow dangerous or a risk, which is something I personally strongly disagree with, because in my view, if an incident occurred at some point on a geographic location, I don't think there's any risk in reporting that later. In fact, I think there is a duty to do this. But because of this concern about giving precise geolocations for venue indents, we quite often have to add some added technology on top that would randomize the geocoordinates to an extent that we can move within 5 or 20 kilometers, be at a random event, which then creates difficulties for people to locating it very precisely, but the sense is there that this increases the security around these sort of incidents. And then what do we do with this data? So we have several outputs where we use this geocoordinate. So what I have here is the global map that we have, where we record all conflict-related events that affect the health sector. And then obviously we need this geocoordinates to sort of locate these, and just to sort of show, you can zoom in there, you can click on the country, then you get sort of the statistics for that specific country, or you can go even further in and then you can read the event description that goes with these individual incident points. And one sort of added aspect here that is sort of a little bit challenging for us in this is that we use underlying map systems. And one thing we've realized is that different mapping systems actually have drawn the borders slightly differently. So if you sort of overlay various maps, you can end up with some events showing in one country on one mapping system and in another on another. And that's, for example, a particular concern in Gaza, where a number of events that are coded on one system as having happened in Gaza appear on another mapping system as being in Israel. And that can then also sort of influence these counts of events in a particular location. So this for us is a challenge that we have not been able to address in a successful manner, and it's something we still have to sort of live with at this stage. Here is another example of a map we have specifically for Ukraine, where we've also included images for some of these events, which people can access by clicking on attacks with photos. And this is another way for us to link location with specific information. We don't have all that many incidents for which we have these photos because it depends on people sending them. There are all these consent issues around this. So that I think to expand something like this, there would be the need for much more collaboration between people who take such images and to sort of share them to make them available. But I think where they are available, they add considerable texture and nuance to particular events. And then just to sort of very quickly show you how we sort of also use this information, this now is for Ukraine for our annual report on safeguarding health in conflict, where we then analyze this data and produce sort of various maps in a general way that all with the intention to provide trend information to inform people of what is broadly happening within a conflict. Here's another example of how we would sometimes sort of do some mapping by just sort of showing how different countries are affected by particular issues over time. And here is another further example of how we use some of the information to make it more visually clear to users, because that's something we sort of find that our end users are not always necessarily very experienced in using geographic information systems. So, for example, for this conflict and hunger for Niger here, we just showed with red dots where the main sort of events are, or in the other example I've put there from Mali, we even used symbols to show where cattle raids took place or where there were attacks on markets. And this is sort of a very visual way of showing that a lot of these events occur along a particular road or a river. So this would be sort of examples of how we use then our geographically located data to try to communicate key findings and insights into particular conflict context. Now, very briefly to the sentiment analysis we are doing, because this, in our view, while not having a direct link to geospatial use, is, in our view, very important to understanding how the sentiment within a particular conflict context changes. And our specific focus is really on understanding the way communities on social media talk about aid agencies, humanitarian organizations, the humanitarian principles, and at what point there is misinformation of what these agencies try to do, when it turns into disinformation, deliberately misrepresenting intentions, or even hate speech that might then lead to violence. And I've also put an example from Mali here, where we also looked at a specific massacre and how the discussions around this played out on social media in relation to a report that the UN had put out. So for us, we believe it's important to put the direct violent incidents that we are recording and geolocating also in a context of a discussion around these particular events. And then to sort of finish, I just wanted to share with you another few forms of how we use geospatial information. And these are satellite images, where we've always used at a time before and after particular incidents, and usually looked at the destruction of particular infrastructure. In this case, usually infrastructure needed for the food systems, and these are all examples from Gaza. And my colleague Timothy Bishop is also here on the call. So if you have more sort of questions on exactly how we're using these satellite images, he would also be happy to talk in more technical detail about it. But the idea here is really to show a before and after, to visualize the extent of infrastructure destruction. And I've put several of these things next to each other as an example of how we've used it. And the idea is not that I now go over this in much detail, but as this presentation is shared, those interested can have a look at it. And all of these images are also available in our reports on food security in Gaza. So with these sort of images, I will finish this short presentation, but leave you also with a few links to some of these geospatial maps that we are producing, as well as the link to our data on the Humanitarian Data Exchange, in case any one of you wanted to use this data and geolocate it on any maps you may be doing. And you'll also find the link to our website there. And in case you're interested, you can subscribe to the mailing list, and then you can receive the various updates of when we're doing information or when new data sets are available. So thank you very much, and I look forward to discussing these issues further. Thank you.
Thank you, Christina. As we move over to Jamon, I am just going to repeat the disclaimer that I forgot to say at the top of the webinar, that I have to say every time. But our speakers here have been invited to share their personal perspectives based upon their considerable scholarship and their amazing experience, but they do not speak on behalf of Harvard. So with that, I'll have Jamon share his screen, and we will transition over.
Thanks, Erica. Thanks, everybody, for joining. Appreciate the opportunity to speak with you all. Is my screen coming through okay?
There it is.
Great. So I'm going to be speaking today, really just continuing one of the themes that Christina was just mentioning on the use of satellite data for monitoring damage in Gaza. My name is Jamon Vanderdyk. I'm an associate professor of geography at Oregon State University. Most of all of the work that you're seeing in this presentation was done in collaboration with Corey Scher, who is a doctoral candidate at City University of New York. So thanks to Corey. So you've seen these kinds of images, of course, in Gaza and other kinds of urban conflicts where we see wholesale damage, destruction to, in some cases, whole apartment buildings, in some cases, city blocks. The work that we're focused on tries to, in a sense, make sense of this level of urban damage that we can see here in early December, mid-December in Rafah City, later in December of 2023, a little bit farther north in North Gaza, similar kinds of level of destruction, perhaps, but a really different kind of urban layout, right? Much bigger blocks, big roadways between buildings here, lots of debris, lots of rubble. And then later on in April in 2024, in one of the most reported upon events, the damage at Al Shifa Hospital. What our work does is try to bring a more of a temporal and geographically comprehensive perspective to this kind of damage monitoring. So rather than looking at images that, as I was just doing, or rather than looking at the usual be these overhead views of satellite imagery, where we look at time 1 and then time 2, we have been using satellite radar data for, in the case of Gaza Strip, for the past year and a couple of months. And we make these, I wish this was on auto loop, but I'm going to keep clicking this. It's only an 11-second long video. We keep making these maps throughout the course of the war to really capture not just the locations of damage, but the patterns, the speed, the tempo, as well as the geographic coverage of the eventual damage. Now, what's so striking about the war in Gaza Strip is just how fast it was at the beginning of it. If you look at this broad region in North Gaza and Gaza, this is, we're seeing any place colored was built up environment before the war. And we see just in these first frames, which really translates to the first couple of weeks and months of this war, so much of the map fills up, especially in the north. And then later, and that's the yellow tones here, that's the light green tones. As we go later into the war, 12 months later, we see more in the south where my cursor is, if you can see that, the blue colors, for example. But that speed, the rate at which the map is filled up with damage is extremely unique to Gaza. There's really no precedent to see this pace of damage over such a short period of time, and then to sustain it as well, right? 12 months in, we're still seeing many of these same places being hit. What I also think is so striking about this map is I'm not showing you any cartography here in terms of the boundaries of the Gaza Strip. The extent of this map, of this damage, the severity of it, in geographic terms, carves out the space of the Gaza Strip, right? Um, Again, this is just such a distinct kind of pattern of damage, comprehensive, and as we'll be talking about through the rest of this presentation, how did we make that kind of map? Well, to make that kind of map and to get 60 observations over the course of the war, we've used Sentinel-1 satellite radar data. This is an animation showing how these two satellites operate in tandem to collect basically strips of the Earth week after week. This is each satellite covers about every 12 days. So between them at nominal times, we can get about 6 days of revisit between these two satellites. But satellite radar data work differently than typical overhead imagery that you'd see. So an overhead image that you would see, say, for a Google base map, or if those of you who are familiar with the actual satellite sensors, Landsat or WorldView or SkySat, those work like this optical sensor positioned roughly above an object, such as a house. Radar works differently in that we see this from the side. We see this coming at an oblique angle. So yes, we can still see the roof of the house, but we're also seeing the side of the house. And for a two-story structure, that's perhaps not as important as it would be, say, for a high-rise apartment building or a multi-floor apartment building, where we could have evidence of damage at different heights throughout the building. It could be a lot of ground floor damage. It could be a lot of rooftop damage. But by looking at radar, we can get that. It's not literally a three-dimensional view, but it's something more of a comprehensive lateral view that we can see in terms of where the damage might be occurring. This is also illustrated on the figure to the right. We see a building that's intact on the left and then destroyed on the right. Destroyed in that it's not crumbled to dust, but the whole structure has collapsed. Now, looking at that intact and destroyed stage of the same building in the sort of middle tier here, when we look from the top in this idealized picture, there's no difference in the roof structure between these two. But we can see this difference if we look at the same kind of, or this building damage through a satellite radar view, where we're sensitive to differences in height, we're sensitive to differences in texture, and over time, then we can look at how things look, say, in a pre-conflict period. We find these stable locations, which is this second bullet point here. We look for stable places before the war, and then we track changes in those places over the course of the war. And those locations and events where we see sudden and significant change in this radar term called coherence, to talk a little bit more about in the next slide, we flag those as places that are likely indications of damage or destruction. And again, because we have these satellites operating constantly, we're sort of in this machine of satellite observation, this massive constellation, right? And so these data are always coming down. Regardless of atmospheric conditions, day, night, it doesn't matter. We're just always collecting these data, so we can develop a kind of persistence to this observation, rather than looking retrospectively, and certainly rather than looking at time one and time two. We do this throughout the course of the war. I mentioned this term coherence. Coherence is a radar concept that can best be thought of as the correlation. It's not exactly correlation, but it's similar. And this map, you can see again, we're looking at Gaza Strip here. You can see as we progress through this map that the areas that are very bright at the beginning, those are going to be indicative of built-up areas, roads, buildings, structures of different kinds. And as we advance through the war, with this sort of flickering view here, we see this slow erosion of those bright white areas. We see the sort of eating away of the stability, the pre-conflict signal. That is the result of urban damage and destruction. We're not literally tracking rubble or something like that here, and this isn't literally a map of damage or the inverse of damage. But you could think about this as a map of stability when or a visualization of video stability when we look frame after frame after frame. And so we see these bright white areas at the beginning here, highly urban, dense environments, and then let's jump to the end. So much of that, what was stable, is just, it looks totally different. It's not as if there's nothing there, it's just a completely different form and structure. So we track this, or we've tracked these kinds of changes over the course of the war. Here's some of the statistics we've put together at the end of a little more than 12 months into the war. We have an estimate of nearly 60% of buildings in the Gaza Strip being damaged or destroyed. That's actually a conservative estimate compared to a couple of other approaches, or a couple of other results that have come out from the United Nations and the World Bank. But you can see this distribution by governorate. You can see how this pace changes over the course of the war. For those of you who are familiar with the sort of dynamics of the early stage of the war, this flatlining in the south here, we have some indications of the ceasefire in November. Again, that rapid rate of change in the North Gaza and Gaza in the blue and purple here, they just shoot up to over 50% in just about less than 6 weeks. The rest of the governorates in the south, further south, take more time, but at the end of this, we're somewhere around 50 to 74% of likely damage of buildings across every governorate. So this is no real other way to say this. This is broad scale damage that results in a map like this, where every red pixel we see here is a building, a region that was likely damaged or destroyed. So this approach, of course, has limitations. We tend to miss damage to small clusters of structures in agricultural or rural areas. Really small structures, we have a nominal resolution of 10 meters of the radar signal. So 10 meters is already kind of big. We have to process that further. But if you have very small structures, we're just not going to be able to track them well in the first case. If we have highly dynamic background conditions, things that push us away from having a notion of stability, like vegetation, agriculture, trees, plantations, etc., that also is right now sort of outside of our ability to capture that. We're working on different methods to try to improve our detection in these areas that are highly variable, but still may have information. But suffice it to say, we have this is one of the sort of front lines of challenges in doing this. We miss these small structures. I have blue on this map. This is from the United Nations Satellite Center, the UNOSAT. So this is a separate assessment of building damage. And so you can see this disagreement, broad agreement, as I'll talk about, but we see these blue areas that are still showing a little bit of difference. Zooming out, we actually do very well. Overall, 99% of those UNOSAT locations are captured if they're stable. So if they're in our stable area, we capture them straight away. And outright, we capture nearly 3/4 of UNOSAT. So this would be based on visual interpretation of a very high resolution commercial imagery. But this is quite promising, since our approach is automated, takes a few hours to run, is scalable over time and space, and we're seeing very broad agreement with a sort of hand-curated, expert-interpreted data set. Now, there are important distinctions between radar and overhead view. This is one of the images taken actually by the IDF. I want to point out there's a lot of happening in this, but if we see these buildings in the background, windows blown out, scorch marks shown on these 3 tall buildings, we see this kind of lateral damage shown in many cases, in part, we think, because of the sort of collateral damage from the shock wave emanating from the detonation of bombs. This is just one example from Financial Times showing the blast effects of this commonly used Mk-82 bomb, where we have this sort of stage of, yes, lethality, but also fragmentation. And this means that within, as they say here, within 31 meters of this blast location, so it's a radius of 31 meters, most buildings will collapse. But of course, there's broader effect, there's other effects as we go farther away from that 31 meters. This is something we're trying to better understand, is just how common building damage, structural damage is likely associated with this kind of bomb detonation. But suffice it to say, we see these evidence of this kind of structural damage that might not be visible from the top. We see that over and over across the Gaza Strip. Other sources of disagreement that we're working on, sort of identifying the reasons for: small clusters of UNOSAT damage here in the blue area, the blue dots highlighted in the green circles. Conversely, there's broad swaths of Gaza where we see radar detected damage that has gone unmapped by UNOSAT, and we're bringing in social media data and other sources to help us understand what are the different causes of that. Now, because we've been tracking this over the course of the war, we have 60 assessments. Since the beginning of the war, we've been making maps and sharing these. So this is all, again, part of this automated cartographic approach, where as soon as we get the satellite radar data, we process it, and then we generate these kinds of maps. These then are shared with these maps, but also the underlying data are shared with different journalist organizations, humanitarian organizations. There's been a very broad uptake of this work. We've seen it mapped in over 300 news articles over the last nearly 14 months. And that's really a global response to this kind of need for these data. We're seeing it across 14 countries, across multiple languages, as we're seeing here in this graphic. Now, in closing, I think that, of course, there's a lot of, we think that there's a lot of value in doing this work, in sharing this work with people who can make decisions on it, who have on the ground opportunities to address one concerning aspect or another, whether it's direction of humanitarian aid, whether it's thinking about recovery and relief, whether it's thinking about documentation. These are all values. One of the things that's emerged, however, is the commonality, the uptake, the sort of shared viewing of the same kind of data. We're seeing this as perhaps a potential pathway towards really finding common ground on the actual consequences of the war, regardless of one's orientation to, say, the legality of the war or the proportionality. These are sort of separate follow-on and important discussions. But at the core of this, having a data set that is replicable, that has transparency in the methodological process, and that is being accessed by different groups, such as Haaretz, an Israeli newspaper on the left, and Channel 12, an Israeli television station on the right. Different, perhaps, narratives being built around these maps, but the same data underneath it all. We can at least have some shared approximation of the damage that's occurred, and then move forward with discussions and decisions from that. Thanks very much for your time, and happy to take any questions.
Great. Thank you so much, Jamon and Christina beforehand. So we would like to move into a Q&A session now. And I know that the audience likely has questions. I think we'd like to kick off the Q&A with a very important question directed towards both speakers, and then we'll move into some audience questions. So I'll ask this question and maybe Christina can answer first and then Jamon. But one thing that we'd really like to hear about, especially as we're considering how this data can be impactful in a atrocity mitigation context, is how have these spatial or informational products in general influenced or potentially influenced policy, programming, or action on the ground. If you could speak to that, please, that would be great. Thank you.
Yeah, I'll briefly start. So if you remember at the beginning of my presentation, I had this slide of these INGOs that we work with, and they are really the main practical, regular users of that data, and in particular for their own security risk management. So what these agencies do is that they assess the environment and how safe or dangerous it is for staff to go into particular areas, or what mitigation measures they need to put in place to actually operate in a particular place. So that's how our project started, to provide aid agencies with this sort of data. And that is the area where I really know it has been regularly used. We are trying to also move it into further policy and programming processes. So some of the images I showed you from Mali, for example, around the food security, we're trying to create an anticipatory mindset where we want to share with, in particular, the aid community, that there are particular incidents happening that will have impact on food security, not today, but in the coming months, because they destroyed the fields, they destroyed the granaries in which people stored food, and that this offers a window of opportunity for aid agencies to act in advance before food insecurity really hits communities, or before communities are displaced, by providing some mitigation action. This is something which we are trying to promote among aid agencies, and we'll have to see to what extent this will actually feed into programming. And we also find that some campaigners, and I mean, maybe it's sort of a little bit similar to what Jamon said about, we also had media using some of the images. So I think it influences the narrative around these events, and in the same way as Jamon said, you know, it depends on your perspective of how you interpret this kind of data. So yeah, thank you. I mean, probably Jamon, you want to say something as well.
Thanks, Christina. Yeah, it's similar. I think I know our data have been used to guide some evacuation efforts. The data have been used to inform the shelter assessment. So one of the tricky things with these remote observations of urban damage is we can make a gradation of, say, light or moderate or severe damage to a building. That may just refer to the roof of that building. It may not have the sort of full view in the sense of the structural condition. We can't get at that full view from satellite-based approaches either. But those buildings that have moderate damage but might still be appropriate for sheltering, those are difficult to detect in an automated way through satellite remote sensing. Total destruction, perhaps the easiest to see, no sign of damage, also easier to detect, characterize, but it's that medium scale, which is really tough, and that's where some of our data have been used by humanitarian actors to better try to understand where some of these safe sheltering locations are. I think a lot of our work as well, we've done this in Gaza, but we have the same kind of data over all of Ukraine. We're mapping Lebanon right now as well, and continuing to map Gaza. But there's a kind of pivot that we're trying to move towards, which isn't quite as explicitly anticipatory as Christina was talking about, but it is a kind of having these data in the hands of decision makers earlier and more consistently, and providing a kind of data set that there's awareness of the limitations and the value at the same time across multiple contexts. So that's building up a kind of literacy and a kind of awareness of what can be done with these data once they are available. So that's something we're very, very early days, seeing how that's actually going to play out as multiple groups use the same kind of radar-based data across Ukraine, Gaza, and Lebanon. But the hope is that that will lead to not just earlier action, but more consistent action, less gaps between these observations. But we're, I think, really early days to see how this is actually all going to play out. Thanks for that. Great question.
Yeah, sure. Thank you both for your very thorough answers. So I see that Daniel has had their hand up since Christina's presentation, actually. So I'm going to give them a chance to go off mute and ask their question if they're ready to do so. Daniel, are you there?
Was a mistaken hand.
Oh, okay.
It says the chat. Accidental hand.
Okay. That happens to us all. Okay, I'm going to briefly read a question that was in the Q&A because I don't think that the whole audience can see the Q&A section, and I think this question might be of interest to others. Isaac asked, from the example that Christina gave about adding pictures to the violent event data set in Ukraine, they asked, do you depend on crowdsourcing to get the photos? If so, how do you check for their authenticity and that people are not staging the content of the pictures? What about the chain of custody of such photos to ensure that they are not altered? And then Christina briefly answered, we work with Eyewitness Global to source the images on the Ukraine map. They are a project of the International Bar Association, and they ensure that there's a full recorded custody of images and confirmed date and location of the photo taken. So I just wanted to go there first. Erica, please.
Thank you. Well, it seems like there's a lot of people who are very interested in how both of you go about validating your spatial products, thinking about SLP and the difficulties with kind of non-codified language and variations in spelling and variations in base maps, and then thinking about like social media and the difficulties with geolocations within social media. I think there's also a question in the chat from Sophie Hayes about asking Jamon to speak more to the validation methods. You mentioned social media. Is this done on a case-by-case basis or automated in some way? Are you using just Unisat for validation? So lots of people here are really curious to hear what you guys are doing with regards to your validation processes.
Well, maybe I briefly sort of start. I mean, as I described in our presentation, we really start with individual incidents. So for us, the validation process starts by looking at the incident, and the initial validation is really around the source and who's reporting it, and also the context. And then, as I said, we put it into these news briefs that we share with people with the link, and encourage communities also to come back to us. And it occasionally happens that people either point out that a source is not trustworthy, or that a particular event is not quite as described, or also the original source updates later. So that's the sort of initial thing. But then there's also the big the question of how do we validate the precise geolocation. And that's a complicated process, because some place names appear in many, the same sort of place name, the equivalent of new city or something occurs in many places. So there can be some confusions around that. And then what I've also already mentioned is this issue with the base map, that sometimes it's on one base map you get a particular location, and on another it's something else, which is sort of somewhat frustrating. And then also when we have these images, as I shared for Ukraine, then it's also a question of matching what we have for this image, what we can see on Google Maps or similar, in terms of to what extent that building structure matches. And I think someone also, Isaac, I think asked earlier, that things are not staged. So we're really looking for damage to the structure. So I think that is somewhat difficult to stage, in particular, the level of destruction it's documentation rather than staging something. So that was a very general answer. It depends on each individual case, but broadly, that's how we do it.
Well, I think for us, we don't use the term validation. We say agreement. Validation suggests a kind of ground truthing that we don't have access to. So that the gold standard is field validated, structural engineering assessed condition of structures. That hasn't happened in Gaza Strip yet. So there is no way to validate it, but we can compare with other remote sensing and other data sets that have been provided. UNOSET, because of the repetition and the open data sharing, is the go-to for, it's sort of the benchmark for a lot of remote sensing based analyses of damage due to war or natural hazard. But they're different. It's apples and oranges. So all we can talk about is the overall sort of commonality, the intersection between the two, and then try to understand reasons that are for the distinctions. We tend to focus a lot on the quality of the data as much as we can. A complete data set on building footprints is the most important thing outside of the remote sensing analysis. So Jesse Peckman, who's on, I think one of the attendees here, was one of the main driving points behind updating the OpenStreetMap data set over the Gaza Strip. That kind of effort where compared to available building reference data sets, now you have many 10,000s more of buildings that come online. That's extremely useful. And it goes to show the pitfalls of using off-the-shelf data when we don't even know how good they are. There is no quality assessment from, say, the Microsoft data set over the Gaza Strip that would have told us actually you're 10, 20% short. That's not available. So that's always a tricky bit. And I think Christina sort of speaking to this too, is at what point do you go forward with your own analysis? At what point do you trust the off-the-shelf stuff? And at what point do you need to really validate every single source of the data that comes into your workflow, or check the quality of it? I shouldn't say validate it. But those are some of the things that we've been worrying about and really fretting over and trying to improve over the course of this work. Another just more general perhaps answer is we try to explore, we run this analysis in areas where we know that there isn't this kind of damage occurring, and we run this analysis pre-conflict to see, are we just picking up tons of changes, period? And yes, we happen to be capturing these also during the war, but these aren't conflict induced. That would be a sign of a false positive, and our false positive rate is below 1% for this kind of work. So we don't, based on that historical analysis, we're not getting that sort of background changes as being flagged. The real question going forward is, what do we do with all of these multiple products coming forward of damage analysis when we have 5, 6 different data sets, including social media, including journalist reports? How do we merge all of these together in a way so that we're not just having 6 different data sets out in the wild and some end user now has to navigate through half a dozen data sets, but how do we make the best of all of them and put them together in a kind of harmonized awareness data set of building level damage? That's something we need to work on.
Great, thank you. Thank you all for your engaging questions and responses. Just a friendly reminder that this webinar recording will be made available to the participants afterwards. And we have just less than 6 minutes left. So I think we will transition over to wrapping it up and our call to action, for which I will pass this over to my colleague, Mads.
Thank you. As you've probably seen, this work is really complex, and there's a lot that we can learn from each other, which is one of the reasons why we created a community of practice. And alluding to what Erica mentioned at the beginning of this session, there are certain gaps in terms of those of us who are in academia or in the West versus those who are not. Those who are at the front lines of doing atrocity prevention versus those who are doing the research. So the COP was set up in order to bridge that divide, because these are issues, atrocities are issues that affect all of us. So I strongly encourage you to join our COP. You can find more information on that on our website, but please reach out to us and we'll be happy to add you to the COP. And also, since I mentioned the website does have a lot of information there already. It wasn't set up that long ago, but we have a blog, we have announcements for both synchronous and asynchronous courses. We have announcements like the one we just had, this presentation, this workshop. Our COP also has a LinkedIn group, which I strongly encourage you to join. And also, since we are talking about bridging the divides, a lot of our work is to actually operationalize a lot of these principles. So we are reaching out to you today to join us to develop case studies where we will help you. We will work with your organizations to implement spatial analytics into the early warning, early response workflows that you are implementing. So please reach out to us for that as well, and we would love to work with you. And finally, please remember to fill out the webinar evaluation survey. This is important for us to continuously improve what we are doing and to demonstrate impact to our sponsors and funders. Thank you.
So with that, I want to thank again everyone for coming, participating. There were so many questions in the chat that we didn't get to. This is a complex conversation, and I really want to thank Jamon and Christina for coming and showing their extraordinary work. Again, this is really about how do we take all of these very cool, very sophisticated methodologies and turn them into something that an end user can process and integrate and really turn into impact in our conflict and atrocity prevention work. So again, I urge you to reach out to us via the COP, go to the website, explore some things, email us. It looks like Christina, they're also looking for people who are interested in collaborating, in working as geomappers or analysts. This is a big world, and I'm really excited that we're going to continue to try to make these connections between us. So with that, I am going to end our webinar. Thank you, everybody.